Hello, welcome to another machine learning video. So this video is basically the continuation of the end-to-end machine learning project from data collection to model deployment. So in the first video, if you didn't watch my lecture 6 or the first part of this end-to-end machine learning project, then I will suggest you to please check my first video and please my description box for the link. Okay, so I told you that any machine learning project or data science project usually go through these 8 basic steps. Okay, so in the first steps you must frame your problem. Okay, you must frame your problem, machine learning problem, and in the second step it is the you have to get your data, getting your data. Third step is discover and visualize the data to gain more insights, and fourth step is prepare the data for machine learning algorithms. So you may consider this as a feature extraction step. Then you have to explore different machine learning model and find out which is your best model for your machine learning task, and then you have to fine tune your model and combine them for a greater solution. So you may use a ensemble model or something. We will discuss this part. And finally you have to present your solutions, and you have to save your model, and you have to launch or deploy your model either in web server or in some web app, or in any other kind of form where people can use your model. Okay, so also you have to deploy some maintenance system for flawlessly use of the flawlessly regular use. Okay, so these are the basic 8 steps which any machine learning project usually go through. So far we have discussed that up to the data preparation step. I think up to the 4th step in my 6th lecture, or the first part of this end-to-end machine learning project. So we basically discussed that the data preparation stage in details. That so it consists of basically 4 more steps, or four individual steps. That first step is the data cleaning step. So here we basically remove the outliers and drop the missing values. In feature selection step, which is an optional step where we select the best feature for the machine learning tasks we are doing. So there are some statistical model based methods that we have discussed in the last video, and then we need to do feature engineering. So feature engineering basically means you have to discretize your feature for some continuous feature values. You may need to do some feature decomposition, you may have to do some feature transformation, or you may have to aggregate the features into get some promising new features. Okay, and finally, before applying the features into the machine learning model, or to train the model, you must scale your features. Either you have to standardize or normalize your features so that you get a better performance, or your training is become a bit faster. Okay, so in this video I am going to discuss these topics further. That is, first I will discuss that what are the machine learning model you may explore for your ML task or machine learning task, and how you are going to fine tune your each model, and how you are going to shortlist the best promising model for the best model for your machine learning task, and finally how you should present your solutions. Okay, so this is a recipe for my for this video. Okay, so far we have I told you that any machine learning project, we know that for different machine learning tasks, we have to explore different machine learning models. And we know that there are two types of basically the machine learning tasks we may in supervised learning. Basically we may have to encounter, that is regression models and classification model for supervised for supervised task or supervised learning. Okay, so in regression we may have to consider these models we may have to explore this model, this linear regression, polynomial regression, SVM regression model, random forest regression model, or regularized linear model. If there is any overfitting is there, then you may have to use regularized linear model, that is ridge, lasso, and elastic net. Okay, and similarly there are popular classification models which are very popular. There is logistic regression, superfactor machine, decision tree, random forest, extra trees, and these are the very popular classification model. And there are some models which are basically your binary classification model, and to do make it to use it in multi-class classification, you have to use either one versus one modeling or one versus rest modeling, so that you can apply them as a apply them for you can use them for multi-class classification problem. Okay, and but we also have seen a paradigm shift in machine learning community that has happened in last few years particularly after 2006, is that if we have a significant amount of data, then you may use artificial neural network for any kind of task. It can be used for regression model, or it can be used for classification model also, right? So there are different types of artificial neural network is there. For third generation artificial neural network, that is fully connected neural network, or convolutional neural network, and recurrent neural network with LSTM or GRU units. So prediction for both, and this neural network can be used for both regression tasks or classification tasks with some particular settings in their architecture. Okay, so this is actually the sub part of your deep learning, and where we may use different layers. You may use several layers in your project. Okay, in your neural network architecture. So fine so fine tuning means basically that is actually to tune the hyperparameter of the model, right? Fine tuning means to tune the hyperparameter of your model and to select the best model. Okay, and for the selection of the best model, you need to do evaluation, right? And you need to do evaluation, and you need to do evaluation. Now you start with any kind of machine learning model that I told you in the last slide, and for any given task. So but there is no guarantee that your that your machine learning model will show best performance with the default parameter or default initialized parameters for any given task. Okay, because every machine learning model has some default hyperparameters which is assigned to them, and you may start with that, but it is not guaranteed that your machine learning model will show best performance with that default parameters, right? And for this you need to and as I already discussed, that machine learning model must not overfit and underfit the data, and that is our ultimate goal for any training algorithm. That we should not underfit the data, or we should not overfit the data. So it should be well balanced. Okay, and to this end, we need to fine tune the model. Okay, And this fine tuning also take care of the bias variance trade-off, which is very much important for any machine learning task. Okay, so bias variance trade-off is is a very important thing, right? And we can get a better generalized model. So we can get a better generalized model if we do a better fine tuning. So fine tuning is a very important step in any machine learning project. Okay, so now let me describe a little bit how we can tune the hyperparameter and find out the best model, select the best model. Okay, so there are basically two options we have in general. Okay, we have two options in general. That is, one is that the holdout validation, and another is that k-fold cross validation. Okay, so so first I will discuss holdout validation. So in holdout validation is basically that the main essence of holdout validation is that you simply hold out some part of the training set to evaluate several candidate models and select the best one. Okay, so usually what we do is basically it is common to use some 80% of the data, uh, for training, and we hold out 20% of data for testing. Okay, so but this 80% and 20% is not sacred. Okay, so this is not sacred because actually it depends on this ratio, this 80-20 ratio, 80% 20% ratio depends on the size of the data set. So if it contains if your total data set contains suppose 10 million instances of or data points, then holding out 1% means your test set will contain almost 100,000 instances, and probably that is good enough for your task. So that because that is good enough to get a good estimate of the generalization error. Okay, so this is completely but usually if you have a standard data set where that is not too large or that is not too small, then it will better you should use this 80% 20% ratio for train set and test set. Okay, so so this new now what we do in holdout validation, what we do that we simply hold out the part of this training set, this training set to evaluate several candidate models and select the best one. So this new held out set is called validation set, or simply we call it a development set or dev set. Okay, so more specifically what I mean to say is that you train multiple models with various hyperparameters on the reduced training set, and that means that full training set minus the validation set, and then you select the model that performs the best on the validation set. And after this holdout validation process, you train the best model on the full training set. That means including this validation set, means it using this 80% data, and this gives you the final trained model. Okay, and lastly you evaluate this final model on the test set to get an estimation of the generalization error. Okay, so this is the overall idea of holdout validations, but there are some problems you may face if you use holdout validation, and because if the validation set is too large, if validation is too large or if the validation set is too small, then model evaluation will be imprecise, and you may end up selecting a you end up selecting a suboptimal model by mistake. And conversely, if the validation is set is too large, then what will happen that then your remaining training set will be much smaller than the full training set. And why this is bad? And because since the final model will be trained on the full training set, and it is not ideal to compare the candidate models trained on a much smaller training set. Okay. And so, and another problem is that due to sample variability between the training set and test set, your model may fail to generalize. Your model may gives a better prediction on training data but fail to generalize on the test data, and this leads to a low training error but a high test error rate. That means high bias and high variance. Okay, so both are they're low bias but high variance, right? And that is not desirable. We want a low bias and low variance scenario. Okay, that is the ideal scenario. So what are the solutions, the way out? So one way to solve this problem is to use cross validation method. Okay, so the cross validation method. So the main concept behind this cross validation method is that we are going to use in cross validation, we are using many small validation set. Okay, so each model, so here we are going basically do that in cross validation. So each model, so we are each model is evaluated once per validation set, and after it is trained on the test of the rest of the data. Okay, and then what we are going to do, we are going to so we are going to train different machine learning, different model by different training set, and it will be evaluated on different validation set, and this way we are going to get different evaluation matrix or evaluation results for different models, trained models, and then you will going to average out the performance. So by right, so let me give you an example that, so suppose for 5-fold cross validations that is shown in this picture, what we are going to do is that for 5-fold cross validation, the dataset would be split into 5 groups. Okay, so dataset is split into 5 groups, and 5 groups, and the model would be trained and tested 5 separate times, so each group would get a chance to be the test set. And so for every splitting we'll get a performance measure, one matrix, that is suppose accuracy or something, F1 score, whatever you what is relevant to your task. So for every split you are going to, for 5 split you are going to get 5 different performance measure. And then finally what we'll do, that I will going to average out all this evaluation of a model, all this metrics of the model, all the performance measure of the model, and you get a much more accurate measure of the performance. Okay, so this is the concept behind the k-fold cross validation or 5-fold cross validation, or k value can be anything, 5, 10, it's up to you. Now obviously the question comes, which one is better in which scenario, right? So holdout method is good to use when you have a very large data set and you are or you are in a time crunch, or you are starting to build an initial model for your machine learning model. So that in that scenario you can simply use a holdout validation process in your machine learning project. When you have a large data set, you should blindly go for this scenario. And on the other hand, the problem with keep in mind that because the cross validation uses multiple trains and test splits, it takes more computational power and time to run than using the holdout method, right? So this is one drawback of cross validation method. Okay, it requires more computational power and more time to run than using the holdout validation method, because it uses multiple train and test splits. Okay, and I forgot to tell one thing in the last slide, that for how you can use this cross validation in Python, you can use grid search cross validation function. Okay, and that is very straightforward. That you can use that scikit-learn's grid search cross validation function to search all the hyperparameters for you. So all you need to do is tell that which hyperparameters you want to experiment with and what values you are going to try out, and it will use cross validation to evaluate all the possible combination of the hyperparameter values. Okay, so this is one method that you can use in scikit-learn, that grid search cross validation method. But one thing but that is not the only way we can do the cross validation or cross validation. That is, if the training is very long, you may prefer a Bayesian optimization approach, and with some Gaussian process prior. And so basically, but grid search cross validation is very popular in machine learning, so you can initially use that method if you have a small data set. Okay, so these are the two techniques, that holdout validation and cross validation, k-fold cross validation, for fine tuning your model. So finally, what you are going to do, you got your tuned model with set hyperparameters. Now you may try this second step, that suppose you fine tune different models, then you may try ensembling them or mixing them, and find out some more fine-tuned and more a better model with a better performance. But this is an optional method. You may only, in the first step, you may only train or fine-tune a single model, and then you can evaluate on the test set. So finally, you have to measure the performance of the model on the test set to estimate the generation error, and make evaluation based on the judicially chosen some metrics associated with your machine learning problem. Okay, so this is the overall way you can train your model, evaluate your model, cross-validate your model, or fine-tune your model, so that you can get the best promising model for your machine learning task. And finally, what you have to do is that you have to present your solutions. Okay, you have to convince all the people associated with your project, and you have to basically explain why and how your solution achieves the objective of your project, and that is the most important steps, and before you finally launch or deploy your model in web server or in some app. Okay, and then also you need to present interesting points if you notice along the way of your project, that what worked and what didn't work for you. Okay, and also I told you that this is very important. You must know intuitively that what are the assumptions that you have taken when you have done this project. So you must list your assumptions, and also you must know what are the limitation of your model, or what is the limitation of the whole ML task that has been solved by you. Okay, so that you must intuitively know these things, understand these things, and you should focus on these things when you present your solution. Okay, And with this, I'm going to end this lecture. And basically, we discussed this last few steps. We basically discussed this last the fifth, sixth, and seventh steps in this video of this end-to-end machine learning project video. And in the next video, I'm going to discuss how you can save this model, how we can deploy this model in some web server on some web app, and how you can deploy a maintenance system for a flawless usage of this of your model. Okay, so we are going to employ the inference model on a web server, and we will discuss this part in the third part of this video. Okay, so with this, if you have any questions or if you have any doubt, please feel free to reach out to me. And thank you for watching. And okay, thank you very much.